At question number 1, it is 17th question of the 2024 LL paper. A steel meter ruler is to be used in a measurement so that millimeter readings are accurate up to 5 into 10 to the power minus 5 millimeters at a certain temperature. What is the maximum temperature variation allowable during the measurement? We can get delta L equals L1 alpha theta. Delta L should be the change of length. It is 5 into 10 to the power minus 5. We have to get initial length as 1 millimeter. This change of length is acceptable for 1 millimeter. Alpha is the linear expansivity. It is given as 1 into 10 to the power minus 5. We have to find temperature variation, temperature difference. Then we can get 5 Celsius. Then answer is 5 for the question number 1. Then second question, it is 28th question of 2024 paper. The absolute humidity of air inside the closed room of volume 75 cubic meters is 0.04 kilograms per cubic meter. And the relative humidity is 75% for the room to be saturated with the water vapor at same temperature. How much additional mass of vapor should be added to the room? We can get relative humidity value is 0.04. It is the vapor mass per unit volume, vapor mass per 1 cubic meter. But volume of room is 75 cubic meters. This one is the total vapor mass in the room. Then if the vapor mass required to saturate is m0, we can divide by m0 and multiply by 100 to get the relative humidity. Relative humidity value is given as 75%. Now we can simplify it to find the value of m0. Then we can obtain 4 kilogram. This one is the vapor mass required to saturate the room. Now 4 kilogram is the required mass, and mass in the room 0.04 times 75. We have to get the difference to obtain the required additional vapor mass. Then we can simplify it. 4 minus 4 into 75, 300. We have to separate 2 decimal places. 4 minus 3, 1 kilogram of water is required. Then answer is 3. Next question. 2 solid spheres A and B are made of the same material with identical surface properties. The diameter of sphere A is half that of sphere B. They are heated to the same temperature and then allowed to cool in the same environment conditions. The initial rate of cooling of A and B are RA and RB respectively. Which of the following is true? I will get the corresponding relationship. We can get heat loss rate is Ka theta minus theta R. It should be equals to ms theta over T. Ms theta is the heat exchange. We have to get divided by 2T to obtain the rate of heat exchange. Then I will mark constant values for both objects. K is constant, same surface properties, and constant temperature difference. Temperature of object and temperature of room is constant for both objects A and B. And same material, therefore S is constant. We can substitute A value, area of a circle, area of a sphere, 4 pi r squared. Should be proportional to, I will use proportional mark because of some constant values are removed. Mass is volume into density, 4 over 3 pi r cube into density. Temperature, cooling rate, theta over T, it is given as R. I will use R. Then we can get 4 phi constant, 4/5/3 constant, and density is constant for both objects because of same material. We can cancel out two R terms, then R is remaining. We can obtain capital R inversely proportional to simple r. Simple R means radius of a sphere. Now they have given diameter of sphere A is half of B. It means radius of B is twice. Diameter is twice, therefore radius also twice. Then heat exchange rate, cooling rate should be half of A. Cooling rate of B should be half of cooling rate of A. Then we can get R A divided by 2. Half of cooling rate of A should be equals to RB. Then we can subject RA. It is 2RB. Then we can obtain fourth one is the correct answer. The next question, it is 33. Question number 33 in 2024 A-level paper. Water of mass 100 grams at 30 degrees Celsius and ice of mass 100 grams at minus 10 degrees Celsius are mixed in an insulated container without any heat exchange with the surrounding. Assume that the specific heat capacity of ice and water 2 into 10 to the power 3 and 4 into 10 to the power 3 respectively, and specific latent heat of fusion of ice is 3 into 10 to the power 5. What is the equilibrium temperature of the mixture? I will calculate heat absorbed to ice, heat absorbed by ice to increase temperature. It is ms theta. Mass 0.1, 100 gram means 0.1. Specific heat capacity of ice 2 into 10 to the power 3, it is 2000. Temperature difference minus 10 to 0, it is 10. Then we can obtain 2000. Then I will consider 2000 joules. Then I will consider heat energy required to melt in ice. It is ml type. There is a latent heat. Mass 0.1, latent heat of fusion 3 into 10 to the power 5. It is 30,000 joules. Then I will consider heat loss of water when cooling from 30 degrees to 0 degrees. Water cooling, temperature decreasement. It is ms theta type. Mass 0.1, specific heat capacity 4000, temperature difference 30 to 0, it is 30. We can simplify it and obtain 12,000 joules. Now we can compare. There is a high energy required to ice becomes 0 degrees water. Therefore, ice will not completely melt. Then equilibrium temperature of system should be 0 degrees. There is a melting ice mass. It is answer is 2. The next question. The PV diagram shown in the figure illustrates a certain thermodynamic cyclic ABCA of an ideal gas. If the temperature of the gas at point A is 327 degrees Celsius, what is the temperature of the gas at point C? They have given a curve like this. A, B, C. We can compare PV product of A and B. And we can obtain there is the same PV product at A and B. Therefore, this process is isothermal process. Temperature constant. Then we can get temperature at this point also 327 degrees. 327 degrees. And we can use this process. It is constant pressure process. Pressure constant. Therefore, I will use V1 over T1 equals V2 over T2 between point B and C. Volume at B 12. I will not use 10 to the power values in axis because of there is a ratio. We can cancel out 10 to the power values. Temperature at this point 327 degrees. It means 600 Kelvin. We have to add 273 to convert Celsius to Kelvin. Volume at point C 9 divide by, we have to find temperature T2. Then we can cancel out 9 divided by 3, 3, 12 divided by 3, 4, 4 divided by 4, 1, 115 to 3. We can obtain T2 value 450 Kelvin. To convert this Kelvin value to Celsius, we have to subtract 273. Then we can obtain 177 degrees. Then answer is 1 for the question number 46 in 2024 paper. Then next question, it is 47. The length of XY, copper bar is L. A half of the bar is properly lagged and remaining half is unlagged. End X is maintained at temperature theta 1 and end Y is at theta 2. Theta 2 is less than theta 1. When the steady state is reached, which graph best represent the variation of temperature along the bar? We can consider temperature variation for the lagged part. For the lagged part, we can obtain there is a straight line like this because of there is a same temperature gradient. But not lagged part, the temperature gradient is like this. Temperature variation is like this because of there is a heat energy loss through the outer surface. Then we can obtain fourth one is the correct answer for question number 47 in 2024 paper.